Hey guys, this is Mr. Grice for Algebra 2 Semester 2 Review, Unit number 4. So we are prepping for finals. This is the first unit we're going to review, and we've got a couple more after this. So just remember to show all your work and to write your final answers on the line. So number 1 says write the slope-intercept equation of the line through the point -9, 4 with a slope of 5/3. Okay, so the two things we need to point out is we have a point and we have a slope. So when we do that, we need to use the point slope formula. I know mathematicians were real creative when they created these names. So here is our equation. The y minus y1 equals your slope, x minus x1. So we have three things that we need to plug in. We need to plug in our point, and then we also need to plug in our slope. Okay, so we have y minus, this was kind of, sorry guys, this is our shell. Okay, now remember which one is your x and which one is your y. So my x is -9. When I plug it back in here, that turns to a +9, and then the y is negative. And then we add our slope of 5/3. Okay, now the first part of the equation stays the same, but then we need to distribute. So we get 5/3 x, and then you need to do 5/3 times 9. Now, depending on what calculator you have, if you have just a little baby calculator, I'm getting mine out, and I have to calc. So if I multiply the first two numbers and then I can divide, I'm going to get my answer. Okay, so that is a +15. Now to solve for y, we have to add 4 to both sides. And then we get our final answer of y equals 5/3 x plus 19. And they asked us to write the final answers on the line. So y equals 5/3 x plus 19. Okay, now for number 2, write the slope-intercept equation of the line perpendicular to y equals 2/7 x minus 11 through 8, 9. Now, once again, they gave us a point, but did they give us a slope? Well, technically they did. They told us 2/7, but I want a line perpendicular to that. So perpendicular means opposite and reciprocal. So I'm going to steal that 2/7 and I'm going to change that to -7/2. Okay, now I'm going to use the same equation we just talked about, the y minus y1. So we have y minus y1 equals our slope, x minus x1. So I know my slope is the -7/2. And now I'm just going to plug in the x and y. So there's my y and there's my x. So our first part is the same, the y minus 9, and then I'm going to start to distribute the -7/2x. And now I need to do -7/2, so -7/2 times -8. Okay? So I know a negative times a negative is a positive, so 7 times 8, and then I'm going to take that number and I'm going to divide it by 2 to get 28. And it's a +28. Okay? And then to solve, I have to add 9 to both sides. 28 plus 9 is, yeah, 20 plus 9 is 37. So sorry, I'm just going to make sure I write this good. -7/2x plus 37. All right, there's 1 and 2. Let's move on to 3. So 3 is saying write the equation in standard form. So when we're writing something in standard form, we had a couple of rules, okay? X and Y had to be on the same side. X could not be negative, or we'll just say X has to be positive. Okay, no fractions, no decimals. Okay, so the first thing that I want to get rid of is I want to get rid of my fraction. Okay, now to get rid of the fraction, I'm just going to multiply by whatever number is there. Okay, so when I do that, 4 times 1 gives me 4y. 4 times 3 is 12. 12 divided by 4 is 3. And if you don't believe me, we did the same thing as we just did. I multiply the top and divide by the denominator. And just remember that it goes to everything. Okay? Now, I want my x and y on the same side, so I'm going to subtract the 3x to the other side. So I've got negative 3x plus 4y equals negative 1. And my x is negative, so how do I change it positive? Do you remember? Well, if it's positive, or if it's negative right now and I want a positive, I'm just going to multiply by a negative 1. And just remember, I need to multiply everything by negative 1. So all of my all of my signs change. So it's negative, now it's positive. It's positive, now it's negative. It's negative, now it's positive. So we get our final answer in standard form, 3x minus 4y equals 1. Okay, domain and range. Do you guys remember all this? Domain is talking about all of your x values. So what I do is when I'm looking at the domain, I just go to where all of these points are, and I write those numbers. So here's my first point from left to right. That is at negative 1, negative 2, negative 3. That's at negative 4. So my domain has negative 4. That's negative 2. That's at 0. That's at 1. And then 3. Okay. Now the range is our y values, and I want these from least to greatest. So I start down here, that point is at negative 4, negative 1, then we're at 2, 3, and 4. Okay? Now, if that's like, whoa, Mr. Grice, that was weird. Another way to do it is just look at each point, okay? My first point right here is negative 4, positive 3. My next point right here is negative 2, negative 1. Okay, my next point is 0, 4. And going through and just writing down all of these values, and then just make sure all the x's and the y's are in order from least to greatest. All right, number 5. If g of x equals 8x plus 4x squared minus 5, find g of negative 3. So all we have to do is take this negative 3 and we're going to substitute it. We're going to plug it in for x. Okay? So I have g of negative 3. Everywhere I see an x, I'm going to plug in that negative 3. Okay? So order of operations, I do exponents first. Negative 3 times negative 3 is 9. Now I can do my multiplication. 8 times -3 is -24. 4 times 9 is 36 minus 5. Okay, left to right, -24 plus 36 is 12, and then 12 minus 5 is 7. So G of -3 equals +7. Okay, that's when they tell you what to plug in. And the next one, they're telling us that f of x, I want that equation to equal -5. So wherever my f of x is, that's where I plug in -5. And then the rest of the equation stays the same. So now if I want to find out what x is, I just have to solve. So to solve for x, we would want to subtract the 7 to both sides. -5 minus 7 is -12. To solve for x, I would need to multiply, and I would multiply by the reciprocal. Okay, a negative times a negative is a positive, so I'm just going to do, I know that it's going to be positive. I'm doing 4 times 12, and then I'm going to divide that number by 3 to get 16. So 16 equals x. What would x have to equal? X would have to equal 16. All right. 7, which of the following relationships also represents functions? List all that apply. So if I want to know if something is a function, I'm going to do the vertical line test, which means if there are 2 points on top of each other, it's not a function, okay? So if you just start going through and drawing lines for every point, well, guess what? That passes the vertical line test, so that's good, okay? We're good, we're good. Ooh, what happens there? So right here, there are 2 points on top of each other, so wah, wah. That doesn't work. See? You're like, well, we're good, we're good, we're good, but when I come to either here or right there, those points, there are hundreds of points all right there, okay? So yeah, that doesn't work. It doesn't pass the test. Okay, last one. Just start trying to draw lines, and I'm trying to find a spot where there's more than one point on top of each other, and I don't see any, so yay, that works. So A and D, those relations are also functions, okay? So that was a crash course in Chapter 4, the parts that we had to do during semester 2. Now, if you have any questions on this or anything else for your final, please come see Ms. Carranza or myself. We would love to help you out. Okay? Otherwise, this is Mr. Grice signing off for Algebra 2, Semester 2 Review, Unit number 4. Thanks for watching.